Hi, I'm following along with Paul McWhorter's Arduino with the Python. We're on lesson number 4, and he gave us homework to try to go out and create an analog meter in VPython. I took up the challenge. It wasn't too hard. So our code from last week didn't change, so we're using the same code just on the Arduino to run into the wiring up our potentiometer and using serial to write it to the PC so we can get the data into Python. One thing there was a discussion in the chat during the live stream where people were wondering about, and Paul also had trouble with his potentiometers. I teach Arduino classes, and this is the one that I like to use. You can get 10 of them for $7 plus shipping. So if anybody's interested, they're very breadboard friendly, and they got a little knob on the top so you can use them, and so they're kind of neat. Got an arrow so you know which way they're pointing. Anyhow, that's just if anybody's looking for a potentiometer, that's a good place to look if you got an Amazon service near you. Okay. So I guess the next thing to do is to go into the code, in the Python code. So our stuff up top is the same. When we go down here into the while true, we're getting our data the same way. And once we have our data, Paul showed us how he likes to do the calculations on turning one data range into another data range. I like to use my function. I'll go back up and show you the function where we can put in a starting range and an ending range and end up with output and the value. So if you paid attention to Paul's, he pretty much did the same calculation up there. Only thing this does, this adds a little bit to it and allows you to have a range, a starting range isn't 0 and an ending range it isn't 0 on both of them, and still does the calculations. So like I say, this is a direct steal from the code behind the map function on Arduino. But I know Paul doesn't like to use code where it's hidden behind the scene. But if you just follow through this line of code here, it's just a condensed version of what he was showing us there, and it put it into a function so that we can use it for different ranges and everything. So anyhow, that works really well. I really like it, especially like I say, we're working here. So on our analog meter, we're going to be putting our dial meter dial is going to be an arrow. And to point the arrow, we need to come up with this vector. So that was the important thing. So and to get a vector to read on point in the right direction on VPython, we use our cosine / sine of the same value and give it a magnitude so that we have the right length of an arrow. But anyhow, when you do this, if you have a value of 0 here, it's going to point all the way to the right. So it's going to be on the x-axis pointing all the way to the right. And remember, go around a circle is 2 pi. So if you go halfway around a circle, it's going to be pi. So if you had a value of pi here, it's going to be pointing straight to the left on the x-axis. So I decided my meter, I wanted it to look like a panel meter that you might find in industry or something like that. So I wanted it to kind of start at this direction and finish over here at this direction. So I didn't want to go all the way to 0, and I didn't want to go all the way back to pi. So my range coming in is 0 to 1023, which is what we're getting off the Arduino. And with our function, it doesn't matter. We're going the opposite way with this. We're going from 4/5 pi to 1/5 pi. 4/5 pi is going to be like over this way, and 1/5 pi is going to be over here. So this will actually do the calculations for us in there when we put it up into the calculation that we have in our function up there. I also wanted to make it a little pretty, so I create a white background for the meter. And then this next box is an opaque, like a clear cover for the meter, a box around the whole meter to make it like airtight or watertight. Then I wanted to put a label on, but I decided to go with 3D text labels rather than just a regular label that doesn't move with your screen. So called this DC voltage and just put it in about the center of the white background there. The cylinder here is the center of the meter, like the axis of the meter dial. So I just wanted to do that, and we're raising it up a little bit just to show a little separation from our numbers in the background there. And then this pretty much just stole this right from our clock projects that we were doing, where you're putting tick marks around. But again, we didn't want to go all the way around, so we're going from 4/5 pi to 1/5 pi. And these are the minor marks, so I wanted to put 25 marks, so it's 26. You have to put 26 here because it's one more than what you had, and it stops one short. And then for each one of those, we're going to draw this little box here to give us a little tick mark. It's a miniature box, and you can see that. And then down here for our major tick marks as well as our numbers, we're doing the same thing. We're just doing the 4/5 to the 1/5, but we want from 0 to 5. So that's 6 numbers, 6 dividing the 6 things there. These are just a little bit bigger boxes. They're going to go over top of what we had. And I wanted to put the text on. So the text was a little bit of a head scratcher. You can position the text the same way we did in the clock. But then when you do the vector to place the text on our clock, we wanted all the numbers to be upright. But I kind of wanted my numbers to follow along the axis of the meter, like you probably would see in a lot of meters out there. So couldn't figure out how to do that. I knew I'd probably need this axis here. But if you just use the vector of the normal way we do it, cosine sine, then it turns them on their side, because the normal axis of a number is along the bottom edge of the number. So that didn't work. So I had to add in this rotate, and we're rotating it by a -1/2 of pi, or pi times half, pi over 2. So that made the numbers right. And that's basically all we did. And then we're creating a red arrow for our dial indicator. And then down here, like I said, back down here, when we get a valid data, we are just updating that axis value. One thing I did want to mention Paul uses what's considered a blocking function up here where um, he's waiting until he gets a reading and doesn't do anything up here until he gets a reading. So in this case, for this little program, it really doesn't matter because we're not doing anything else. But if you want to be able to keep doing things like, maybe you got something, a ball bouncing or something in another part of your screen or something, and you wanted to update that, then you really don't want to do the blocking move. So I changed it to if the in waiting is, if it's not greater than 0, then I just falls out of this if and just keeps going around. So you could do whatever else you wanted down here in your code, bounce a ball or, whatever you wanted to do down here. And that way you don't have to block your code. I always try to do non-blocking if I can do it. So Paul's probably going to get around to that non-blocking thing eventually, but I just know that non-blocking is a better thing. All right, so I guess we can go to I think I already have it running over here. So we can go to our DC voltage here. I can show it operating, I guess. We can just go from 0 up to 5. Leave it wherever we want it. And like I said, this is actually 3D. It's just your perspective that it looks like it's got a ring around it because you're actually looking through with a square thing. So if we got it there, like I said, I just got a clear opacity down to about 0.4 so that you can see through it, but it looks, you can definitely see that there's a box around it like a plastic cover, and then the back is just another white rectangle. And like you said, you can see the numbers are 3D and sticking out a little bit, just like we did for our clock. The dial axis indicator down there, this little black thing, you can see we got it standing off, and then the arrow itself is standing off so that you're not making it as realistic as you can in there. So anyhow, that's my homework for today, and look forward to where Paul takes us next. Have a good day.